Good day. My name is Rina Maharaj, down joined by Swastika Chaturgun, and today we are presenting our Brownfields presentation. Now handing it off to Swastir for section A and B and C.
Okay, hi, my name is Swastir. I'm going to be presenting section A, B, and C for Brownfield development of our Robot World game. So let's kick off with section A. So, software development source files. Does the demonstration ensure that correct source files are identified? Yes. The project accurately identifies source files such as robot.java, json.java, multiserver.java, and the POM XML file, configuration file. These files are crucial for the functionality of the project, handling robot behavior, JSON parsing, server management, and Maven configuration, respectively. Does the demonstration ensure that the correct versions of additional files associated with the software development source files are identified? Indeed, the project specifies the correct versions of additional files through its dependencies in the pom.xml file. For instance, it includes dependencies such as the JUnit Jupyter Engine, JSON, GSON, Jackson Database, SQLite, JDBC, the Javelin, Mockito Core, Self4J Simple, Unirest Java, and others, with specific version numbers. These dependencies are crucial for various functionalities such as testing, JSON parsing, database binding and handling, web server implementation, and more. Additionally, the project utilizes the Jackson Data Bind library for JSON processing, ensuring compatibility and consistency across different components. Section B, Code and Design Conformance. So, our visual design starts off with a flow chart or a flow diagram on how our project works. Not the game, but our project as a skeleton. So, step one, we start our server. Our server is written in Java and hosted in Java. So, it is the Apache Javelin server. We start up the server, which is locally on a single machine. The server initializes and is given a port number, and then another user, another player can connect as a client. So they send the request, and that request is to connect to the host, to the server with that specific port number, and the server will identify the client using their IP address. The client sends a request, the server processes that request, and we make use of APIs to do our processing for this project, and it sends a response. Now, that response will either be connected or not allowed to connect. Once connected, it, the client can send messages or requests and receive responses from the server back and forth. For example, when the client wants to reload or attack, it sends a request to the server, and the server will then respond with the respective action. Our presentation showcases the adherence of our program code to specifications, ensuring alignment with design requirements. The demonstrated code is meticulously crafted to fulfill specifications, promoting clarity and functionality throughout the program. Furthermore, we highlight the methods employed to access data within our program, emphasizing efficient data retrieval and manipulation techniques. Names within our program are carefully selected to accurately reflect the purpose of each item, enhancing code readability and maintainability. While adhering to design documentation, any deviations are documented with clear explanations for their necessity. Our presentation also outlines our comprehensive test strategy encompassing stress testing and result recording to ensure robust program functionality and conformance with user expectations. Section C, Database Management Systems. The Java code employs SQL to interact with a database named Robot Worlds. For restoration purposes, initially it establishes a JDBC connection to the SQLite database. The restore command class facilitates the process by prompting users to input the name of the world they wish to restore. Upon validation of the world's existence in the database, its details are retrieved, including size and optical data using SQL queries. The retrieved information is then utilized to restore the specified world within the simulation environment. Additionally, the code showcases an alternative method for reading data from the robot world table through SQL select queries, demonstrating SQL's versatility in handling database operations effectively within Java applications. Our presentation dives into the pivotal role of database management systems in addressing data management challenges. We illustrate common issues like data inconsistency and redundancy, emphasizing how a database management system centralizes data storage, enforces integrity, and enhances scalability. We discuss key features like data modeling, concurrency control, and security in commercial DBMS, elucidating their significance in resolving data management issues. Furthermore, we shed light on the diverse landscape of database management system types, including relational, object oriented, and document oriented databases, showcasing their unique characteristics and use cases. Additionally, we explore database management systems end user tools, outlining their capabilities in data querying, reporting, and visualization, while acknowledging their limitation in customization and scalability. Our presentation delves into the specific database access requirements and objectives for our project, emphasizing efficient data retrieval, transaction management, and data integrity maintenance. We showcase a meticulously designed database structure that adheres to third normal form, ensuring optimal data organization and integrity through primary and foreign key consistency. Finally, we discuss the critical performance factors and key relationships within our database structures, underscoring the importance of primary and foreign key consistency in maintaining referential integrity. We conclude by emphasizing the holistic approach to database management, encompassing user requirements, structural design, and SQL. Now, I'm going to hand you over to Renan to take care of section D, E, and F.
Cool. I will now be presenting a few things for our project, showing you our design adherence and how we handled, just sorting out our design flow for the program. Let me just share my screen. I'm now going to be presenting our GitLab to you. So this here is our GitLab. Here you can see all the files within the program. We have everything within the main program in our source file. We also include a few things, such as a Docker file, a pom.xml, and a makefile. For the pom.xml, a few main things for this was the dependency management, the build configuration, project information, plugin configuration, and the lifecycle management. So for the dependency management, the pom.xml specifies dependencies requirements by the project, including the libraries and the plugins. This is so when someone who doesn't have all these wants to download the program and use it, it automatically does those things for said user. Build configuration. It defines how the project should be built, including compiling source code, running the test, and packaging artifacts. Project information contains metadata about the project, such as its name, its version, description, and the developers. Plugin configuration. Configurations vary made on plugins using the project for tasks like compiling code, generating documentation, and executing tests. Now, for the makefile, the main points of the makefile were the build automation. So the build automation contains rules for building the projects, specifying how source files are compiled and linked to create executable programs or other artifacts. Dependency tracking is next for Makefile. It tracks dependencies between files, ensuring that only the necessary components are rebuilt when source files are modified. That can be demonstrated by it running the test and it compiling stuff through Maven. Next, I will be showing you all our issue board. This is how we sorted out our tasks for the project. We had a backlog ready for development, in development, a review and testing, and ready for showcase. So all our ideas that didn't come to fruition yet were put into the backlog. Once we said, okay, this is a task that we are going to complete, that we are ready for developments, it then goes ready for developments. And once one of the developers are ready to tackle said issue, it then goes to in development. And once said program, once said file is done, or once said part of the file is done, it goes away into review and testing, where another developer will test if that code works. This is so we don't have issues when people commit code to the source. So this stops code from breaking. It stops people from doing things that break stuff that other people have done. And how we sorted it out was we had milestones, uh, compartmentalizing all our different iterations. Now I'll be moving on to section D. Evaluating SQL implementation and data management in web applications. Section D. Our presentation showcases the seamless integration of SQL within our program, design, leveraging SQL queries for efficient data management. The SQL code presented is highly understandable, ensuring clarity and ease of comprehension. Moreover, we demonstrate the utilization of SQL functionality to optimize queries, enhancing performance and scalability. Additionally, our demonstration highlights SQL's functionality that enhances code readability, facilitating maintenance and future development. We emphasize the necessity of each joint SQL query, their role to retrieve cohesive data sets while preserving data integrity. Methods of accessing data for our program are meticulously outlined, ensuring streamlined data retrieval and manipulating processes. Furthermore, our presentation showcases the effective use of data sharing within the application, fostering collaboration and data consistency across multiple users and processes. We delve into the underlying technologies that bridge databases websites, enabling seamless data exchange and synchronization. Additionally, methods of linking web pages to backend priority applications are demonstrated, ensuring a cohesive user experience. Lastly, our demonstration underscores the importance of well commented code, enhancing code maintainability and fostering collaboration amongst developers. Through clear and concise comments, we ensure that the logic and functionality of our SQL code are easily understandable by both current and future contributors. Section E. Evaluating test execution and database verification in software testing. Our demonstration meticulously executes the operational steps outlined in the test plan, ensuring comprehensive coverage of program functionality, inputs data specified in the test plan is precisely utilized during test, validating the program's behavior under various different conditions. Any deviation from the test plans are documented within clear explanation, maintaining transparency and facilitating effective troubleshooting. We adhere to the standards and procedures specified in the test plan for both initial testing and retesting, ensuring consistency and reliability in testing our approach. The demonstration showcases the thorough testing of programs and our logic parts, identifying and addressing potential vulnerabilities. Furthermore, errors identified through testing of bounce-based accessing using SQL are systematically eliminated, guaranteeing data integrity and accuracy. Through rigorous testing, we verify the database access functions seamlessly in the required environments and performance according to specified requirements. Records for all tests executed during the test of the program are diligently maintained, providing a comprehensive overview of testing outcomes. Variations for expected test results are identified, with reasons provided where available, enabling targeted corrective actions and continuous improvements. Our demonstration ensures that recorded results can be produced under the same conditions, facilitating reliable testing and validation processes. By this, I mean that when we're adding new implementations to the program, we cannot break previous tests or previous functionalities added. It all must work together cohesively. Results are recorded in a structured manner, allowing for easy review and analysis to drive improvements in the application testing process. Throughout the testing process, we adhere to organization policies and procedures, promoting consistency and alignment with industry best practices. Section F, evaluating documentation, consistency, and design adherence in computer program presentations. Our presentation showcases documentation meticulously crafted according to a pre-created design, ensuring consistency and adherence to established standards. Each documentation component is carefully presented in alignment with the predetermined design, promoting clarity and coherence throughout the documentation. We identify whether documentation was created consistent with the computer program being documented, that all aspects are accurately represented and reflected in the documentation. Additionally, we also assess whether documentation was created according to the design outline and the specific outcome, plan and design documentation, ensuring alignment with predetermined specifications. This means that we made sure that everything we want to develop was always in line with previous outcomes as well. Our presentation meticulously structures documentation in a sensible manner, facilitating easy comprehension and navigation. We define how the program specification has met within the documentation, providing clear links between program functionality and documented features, ensuring comprehensive coverage and program specifications. I am now going to once again show you our GitLab just to show you how we got the documentation all in order. So once again, we're on the GitLab. If we go to planning, we can see we have a wiki. And in this wiki, we just had our link to our Miro board, which then had all our design processes and everything in order. Also back onto the milestones. This is where we told everyone what we wanted to do for each section, for each different iteration of the program, all our different issues, each different merge request, all our labels and our instructions of what to do. And how we structured this was each implemented feature that we wanted. For example, see the world. We had different scenarios to test within that one specific feature. So for each feature, we had different scenarios. As you can see, so this changed the way the server handles the client. We had scenario 1A, 1C, 1B, and this is how we basically got around testing the program. I am now going to show you the code and our tests. So this is our code. We have the main and we have our tests. So let me just show you some of the server side quickly and show you some of our coding processes. So we use an agile method of coding. This says that we don't want a lot of redundancy when we coding. We want everything to be sorted out properly. We want everything to be compartmentalized. We want to make sure it's as readable as possible. This is why we implemented strategies such as proper code health, making sure the code structure, code format is all in a way that was adhering to those principles. Also for the testing as well, we had different tests testing the client side and the server side. We made sure to properly and meticulously test different features within the program. also implementing different scenarios of testing within the program as well. I will now run the test for you. As you can see, we have not added any obstacles into the world yet, but everything else has been passing 100%. Thank you. My name is Vinay Maharaj, and that will be our Robot World's Brownfields presentation. Thank you.
Thank you. My name is Swastir, together with Renan Maharaj, presenting our Brownfields Development Robot World presentation for We Think Code and seta 2023. With myself and Renan, signing out.